Somewhere on your machine right now is a folder full of your own thinking. Notes, documents, saved articles, half-finished plans, and no way to ask it a question. Today we fix that, and we fix it with everything this course has taught you. This is the capstone. One complete working application, a local AI that reads your files and answers questions about them with citations. It runs entirely on your machine, private by construction, no API key anywhere. By the end of this episode, you will know the full architecture of a real RAG application. You will know what each of its 4 files does and why. And you will know exactly where it will break first and which episode of this course fixes each break. Every line is in the companion repo linked below. This is a build-along. Pause, run, continue. Quick note before we dig in. If you find this useful, subscribe and drop a topic you want explained in the comments. Now, let us get into it. First, see the whole machine from above because you have already met every part of it. 2 models from Ollama, a small chat model, and an embedding model. Episodes 7 and 3. 1 vector database, Chroma, the local starter from the vector database episode. And 2 scripts of our own. An ingest pipeline reads your folder and fills the database, the indexing half of RAG from episode 14. A chat loop retrieves and answers the query half. That is the entire system. 4 moving parts, maybe 150 lines of Python. And none of it is boilerplate. Every line exists because of a concept you already understand. That is the real point of tonight, watching theory snap into place as running code. Setup is 3 commands, all from the Starter Kit episode's toolbox. Pull the chat model. Pull the embedding model. Create the project with Uv, adding just 2 packages, the Ollama client and Chroma. Notice what we are not installing. No framework, no LangChain, no cloud SDK. The frameworks episode taught when orchestration layers earn their keep. A first build is exactly when they do not. We want to touch the raw pieces once. After that, every framework you meet is just an abbreviation for code you have personally written. Now the ingest script, and we build it in the order the data flows. It walks your notes folder and reads every text and markdown file. Then comes the decision, the chunking episode called Make or Break. It splits each document into chunks of about 300 words, with a 50-word overlap between neighbors. Remember why. Embeddings compress a whole passage into 1 vector, so a chunk needs to be 1 coherent thought. Too big, and the meaning blurs. Too small, and the context dies. The overlap keeps a sentence that straddles a boundary from being orphaned. Each chunk then goes to the embedding model, not the chat model, the specialist from episode 3. It comes back as a vector, that list of numbers placing its meaning at a point in space. And each vector lands in Chroma with 2 companions, the original text and a metadata tag recording which file it came from. That tag is not bookkeeping. It is the citation your future answers will stand on. And here is the real thing running. 2 model polls, 1 ingest command, and every file reports its chunks as they land in the store. The whole folder becomes a searchable space of meaning in seconds. Then the chat loop, and this is where episode 14's diagram becomes 20 lines of code. Your question comes in and gets embedded, same embedding model, same space. A question and its answer live near each other there. That is the entire premise of retrieval. Chroma runs the search you now understand from the math episode, cosine similarity to measure closeness, HNSW to find the neighbors fast. It hands back the top 4 chunks with their sources. Then we do the step that makes RAG honest. We build the prompt in plain sight. A system instruction. First, answer from the provided context, cite your sources, and if the context does not contain the answer, say so. Then the retrieved chunks, labeled by source. Then the question. That is context engineering from episode 43 at its most literal. We are deciding, token by token, what the model gets to see. And the model, the small local one, answers with the retrieved facts under its nose. It streams token by token to your terminal. The way episode 1 taught you it always works. Now run the chat loop and ask it something buried in your own notes. This is a real session, unedited. The question goes in, and the answer comes back with the source file cited on every claim. There is a moment here that is worth the whole course. The first time it answers with a fact you wrote months ago and cites the file it came from, and nothing about it is magic to you anymore. You watched every step. File to chunk, chunk to vector, question to neighbors, neighbors to prompt, prompt to answer. The mystery is gone and the capability remains. That trade is what understanding buys. Now the honest part, because 150 lines is a beginning. The difference between a demo and a product is knowing where it breaks. It will break, and each break has an episode. First failure, retrieval brings back a plausible-looking chunk that does not actually answer the question. That is the re-ranking episode's problem. The fix is retrieving more candidates and letting a re-ranker pick. Second, answers ignore the context and the model freelances from its training. Tighten the system prompt and lower the temperature using episode 5's dials. Then test with the evals episode's discipline, a small fixed set of questions with known answers run after every change. Improvement gets measured, not vibed. Third, multi-step questions that need information connected across files. That is the ceiling of plain vectors. The GraphRag and Agentic RAG episodes are the doors out. Fourth, if anyone but you will ever type into it, the prompt injection episode applies the moment your documents contain text you did not write. A saved web page with hostile instructions is inside your trust boundary now. The repo's README maps each failure to its episode. That map is the curriculum in reverse. You now debug with the same theory you learned it from. And one upgrade is special because it closes the course's loop. Swap the chat model's name for the model you fine-tuned last episode. One string. Now it is your retrieval pipeline, feeding your custom model over your documents. Every layer of the stack, from tokens to training, running under your fingers on hardware you own. So how does this land depending on who you are? As an individual, this project is the portfolio piece. Not because the code is hard, but because in an interview you can explain every line's reason for existing. That is precisely what separates candidates who used AI from candidates who understand it. As a startup, this architecture, ingest, store, retrieve, prompt, answer, evaluate, is the skeleton of nearly every chat with your data product on the market. What you charge for is everything around it: retrieval quality, evals, guardrails, the unglamorous excellence. And as a large enterprise, note what this episode just demonstrated. A fully private document assistant on internal data, running behind your firewall, built from free components in an afternoon. That is your pilot, and the compliance conversation it unlocks is the real deliverable. Let us bring it home with the recap of the episode and of the road. What you built today: an ingest pipeline that chunks with overlap and embeds your files into Chroma. A chat loop that embeds the question, retrieves by similarity, assembles an honest cited prompt, and answers locally. And the failure map that turns every future bug into a known episode. What you built across 48 episodes is bigger. From what a token is, to how attention thinks, through retrieval, agents, memory, production, training, and security, to a machine on your own desk that runs all of it at once. You did not keep up with AI by chasing. You understood it from the bottom, and now the new releases land in a map you own. The frontier will keep moving. Subscribe, and I will keep taking it apart with you, all the way down to how it actually works. That is the core of it. If this helped, hit like and subscribe, ring the bell for the next deep dive, and tell me in the comments what you want broken down next. Thanks for watching.